It's a great honor to start the next research session on socio-technical frameworks, crypto-economic incentives, and implementations. We have with us Jennifer Lee, a PhD student from Northumbria University, then Hunhevicz, who was the main driving force, along with Daniel Hall, of the first research workshop in blockchain in construction last year, who comes from ETH Zurich and the chair of industrial construction by Professor Hall, and Dr. Michele Nati, who is the head of infrastructure development for the IOTA Foundation, going last. We will have essentially 20 minutes, more or less, each to present their work. And then we will culminate with a 30-minute discussion at the end. So please be patient and keep any questions you might have. You can feed them in the chat or on the Discord server, or keep them so you can ask them in the end. So I'd like to invite Jennifer. If you could, hello, welcome.
Okay, well, thanks very much for inviting me, Theo, and the rest of the team working on the workshop. I was at the workshop last year in Zurich, and I found it really, really useful. And it's been really good to meet other people and other PhD students in particularly who are investigating the same sort of field. I've been doing my research for a little over 3 years now, and when I started, I didn't know really any other people that were researching this field, and now there's really quite a lot of people. So it's really nice to see this kind of network building over time. The primary focus of my research is to look at implementation of DLT for the sector, and I use the term distributed ledger technology just because it's more of my approach is quite generic in terms of the technology. It's not blockchain specific. It's not, I'm not advocating on one type of ledger or not. So I tend to use the more generic term. So what I'll talk about today is the importance of socio-technical systems and why the social side of blockchain is just as important as the technical side, and kind of how that's developed over my PhD. So to start with, socio-technical systems really is just about the relationship between the technology, so a technological system, and the social interactions of that system. So the technology is something that we can create and that will meet the needs of what we're asking for, but quite often people ask for something, for a technological system to meet a requirement, but it's actually not the requirements that they need. It's not what they have delivered is not necessarily what is required to solve the problem that they're looking at. So typically, there's been a focus on either the technology or society, and that's resulted in that kind of oversimplification of the use of the design of the technology and the use of it. So you kind of have that mismatch, really. So there's quite a lot of research on socio-technical systems theory, and it's really about looking at the diversity of users and how people use systems, and try and reduce the amount of complexity for the user. And the construction industry exists to fulfill societal functions. So we construct buildings, we construct the built environment, and we create kind of networks and systems around that to make that function, and it's all for the purposes of society. So we can't forget that when we're building these things and we're creating these systems. And it's very dependent on effective collaboration and information sharing, and that really doesn't matter what size the project is. I mean, an example I would give you is that my mum at the moment is going through a small extension to her house. It's about £100,000 project in total. And there's a lot of different people involved in that. You've got your builder, you've got your architect, there's the electrician, the plumber, the kitchen fitter, the joiner, all these different organizations just for this one small project that have to come together, and they have to integrate and they have to communicate, because they need to know what their role is in this project and when they need to come on site to do the work, and make sure that the design is suitable for all of those different things to work together. And that's just one small project. And we talk about billions of pounds for different projects or millions of pounds. You have hundreds of different contractors, thousands sometimes. All of those different people all work on one contract. And they're all from different organizations and they have different processes and different cultures, but they all have to work together, and you have to think about what the social system looks like to be able to deliver those projects. So there's this idea of interpretive flexibility, and this is really about how people use a system, and it's not necessarily how it's designed to be used. And it's this kind of, you know, when you create this technological system, you have an idea, so you've got a problem you want to solve, you come up with a solution and then you deploy it, and quite often it doesn't work, or just because how it's been designed meets the brief for the technology that was being asked for, but it doesn't link in with how people actually operate day to day. It doesn't match in with the processes of an organization or a project. And people use things in different ways. People have, so the idea of this multi-party contract, and you have all these different cultures working together and different processes and different ways of doing things, but you want them to all work on the same system and all use the same sort of, the same data and the same code and everything, and it just doesn't really, and this is the problem we have when we look at interoperability issues. So what's really important is to have the developers work with the users in quite closely when you're developing and trialing new technologies. And I would say that's definitely the case for distributed ledger technologies as well. So this is where the idea of use cases can come in and help a lot, and try and reduce uncertainty of a new system. And I mean, you know, when I say the term use case, I mean the actual kind of the application of the concept of a use case, which is where you take this new system and you sit down with the users and you say, okay, so here's the process. How do you use it? What are all the different ways that you interact with it, whether it was designed in or not? Because people will sit down and use a system and they use it in the way they want to use it, not the way necessarily the way that it was designed to be used. And so the use case will take an application and we'll look at all of the different ways that this system should work, and all of the different ways that these people want to use the system, and then kind of create a technology that would meet both kind of requirements. So you have this design and this use, and they're distinct things, but they're so closely linked that you can't separate one from the other. And these are just a couple of examples of models that academics have come up with around socio-technical systems. The first one on the left-hand side is from Frank Giels, and his was a kind of a sectoral model. So you can see here we're looking at the actual artifact, whether that's a building or if it's kind of different things that you'd use in the built environment, and how you actually deploy that, whether you have networks, markets, infrastructure related to that, and then how people use that system. And it's how you integrate with the two. And this concept of regulation that prompts trust. And at the moment, we don't have anything, you know, we're working in an environment, we're looking at research and technology around distributed ledger technologies, and there's no regulation. So we don't have that trust. We don't have that support of this regulated system. And it's still very new, as we talked, there was discussion about that in the last session, that this technology just hasn't had the chance to kind of evolve yet, and all of the problems that exist and challenges that exist with the technology will be solved, but you still have the issue of how people will actually integrate and use it day to day. So how does that kind of translate through to the construction sector then? So here are just some kind of anecdotal ideas of how the social considerations impact or integrate with this DLT system. So you know, one of the proposed applications for DLT is to automate current processes and activities on site, for example, which is great. But the social considerations are around, you know, it's not just this, but you've got the issue of job displacement, and with the growing population over time and less jobs available, how do you actually service that society? So these are so it's great to automate things, you remove human error, you make things cheaper, you make things faster, but at the same time, you still have this whole population of people that need to work to be able to support themselves and their families. Immutability of record keeping, transactions and data is great, but at the same time, what happens around GDPR? And there's quite a lot of research going on around that. And what if somebody puts some information on the blockchain by mistake? So it's commercial information that shouldn't be out there, and then you can't remove it. So what are the processes around that, and how do you actually separate what you can and can't do with the system? Around contracts, they remove ambiguity. So you might have kind of more standardized contracts, the use of smart contracts, but then you remove the flexibility. And one of the things about construction contracts is they need that flexibility because they're written months, sometimes years ahead of when the work in the contract is actually going to be delivered. So you don't have that kind of certainty of how things will play out. So you need a little bit of flexibility in there. So how does it work if you code a smart contract at the beginning or at some point in the contract, to the construction contract, when you deploy that, and then you don't have the flexibility to be able to deliver the project in the way that it needs to be delivered. And I've put here enable or force new business models. There's not necessarily always going to be winners for that kind of idea. So if we think about the main contractor at the moment, I think a lot of main contractors are starting to engage in DLT research, potential applications, but at the same time, it seems that when you look at new payment structures and new kind of business models, they're the ones that will lose out because they're being forced to change their practices. And a lot of people would argue that that's a good thing because they need to change. But at the same time, this impacts an awful lot of people, and changing a business model overnight is not an easy thing to do. And finally, digitalizing current practices. You have the issue around integration in systems and how actually you use those systems. So you can create this technology, but if it's not user-friendly, people just won't use it. So a lot of these things that the technology can do are great, but at the same time, you have to think about how that actually translates into the real world. So the work that I've been doing over the last few years is creating a framework that will look to support implementation of the technology in the construction sector. And there's a few different aspects that I'm looking at to do this, so I'll just talk through those now. The first thing, I think when you look to solve any sort of solution, any problem, is to look at what the challenges are that you're solving. It's really important to kind of understand the challenge itself, but also the root cause of those challenges. So this is some work that I've been doing that hopefully will be published in the next couple of months, that identified from literature over 400 different challenges, or subsets of challenges within the sector across these different applications here. So we've got information management, contract management delivery, for example. And the majority of those issues are actually human-centric. They're around lack of kind of trust and collaboration. They're not really to do with the technology. The problems that we've got in construction can be solved by technology, but they're not rooted in technology. So it's really important to understand the environment before you start to fix it. So this is where these kind of models that I'm developing come in, that act as these kind of analytical tools to help you understand the environment that you're in. It helps you think about what we are, how we are now, how we operate, what's the problem, and what do we want to become, how do we want to change that. And to do that, we kind of can use these different lenses from the social technical systems. We've got the society and technology, but we also have processes and policy that are kind of they form the system as a whole, but it allows you to break down each different section and look at, who the people that are involved in solving particular challenges or realizing particular benefits from implementation of distributed ledger technology. So you have this model here that helps you look at different parts of the problem, parts of the project, parts of whatever it is you're trying to solve through DLT, and think about all of the different people that will be involved. It's that kind of analytical tool that helps you really understand what it is you want to do. Another part of the framework is identifying the benefits. So it's great to know what the problems are, but then you want to know how this actually will benefit you in the long term. So what are the issues that you're going to solve? So here we've got an example of the iContract, which is a project that's being done by Alan McNamara at the University of New South Wales. So I'm working with him at the moment on the last part of my PhD to take a couple of applications and look at where they are at the moment, what are the problems they're trying to solve. So that's all of these here. And there's probably about 100 or so kind of sub-challenges behind all of these issues here. So if we look at a DLT-based application, these are the different technologies that we'd need to kind of deliver that on site or within a project. And bringing those things together, and if you create this kind of iContract, which is a digitalized construction contract effectively that will run on smart contracts, these are all the different benefits that could be delivered by that application. Now, this application represents major disruption for the sector. If it's implemented in its entirety, and I think it will probably take quite a few years to get to that point, but we can start to use elements of this contract and start to, as Alan's planning, to start to kind of pilot this in the next few months, just to kind of test it out and see how it works in the real world, basically. And this kind of thing is something that would be developed over time. But you can support business justifications for doing the work, for researching DLT or potentially using it as an application. And it can be used as kind of a baseline to say, okay, so have we solved any of these challenges yet? Have we realized these benefits, and to the extent, what's the extent of the benefits? Can we quantify them? And is it really worth continuing with based on the cost and benefit that you receive from investing in that cost? And the final part that I'm working on at the moment is to build a strategic roadmap that will support implementation of DLT applications. So this is the 3 applications where I'm looking at kind of scenario building methodology, which is to say, this is what the future might look like in 5 years, for example. And how would these applications operate? Would they be realized in that kind of environment? So if you have a government that's very engaging in DLT and providing a lot of support and research to support that, that's great. But if you don't have that, how difficult is it to actually realize these applications, and what things do we need to do as a sector? So I'm engaging with the people that are actually developing these applications. But then I'm also reaching out to industry participants to attend a workshop to think about, what we can do as a sector. So, to work with government to develop standards and processes, to also think about how we can support organizations that either financially or with training and actually to be able to implement these systems and that kind of thing. So hopefully what will come out of these workshops is a strategic roadmap that will support that development over the next few years. So just in summary, it's really important to understand the environment. What's the social environment that you're trying to solve? So how are you actually going to deliver this technology, and how do people use it? What's the root cause? So if one of the big problems in construction is collaboration. But why is there a lack of collaboration? Because if you don't understand that, then how can you solve the problem in the first place? And this coupling of kind of design and users working together is really important, because just because the system's designed in a certain way, people aren't always going to use it in that way. So my focus is really around working as a sector to create this kind of ecosystem that will allow these technologies and DLT and smart contracts to be successful. So hopefully it will produce something that will kind of lead to further work around this subject once I finish my PhD. So thanks very much for your time. Just before I finish, there's just for those of you that are interested, I set up a few months ago a LinkedIn group, which is for PhD researchers, but also kind of early career researchers, master's students, people who have students that are doing this kind of research, just as a place to kind of share information about events, upcoming events, papers that are coming out, things that might be interesting or important for kind of researchers to know. Just I think when I started out, it would have been really useful to me to have that information. So I wanted to kind of create something for people that had that kind of group. So if you're interested in joining, just do a search on LinkedIn, and then I can admit you to that group, and hopefully it can be a bit of extra support for you. So that's me. So thank you very much.
Thank you so much, Jennifer. Fantastic work. Well, I have lots of questions, but I'll keep them for the end. And if you're a PhD student or a master student and you're researching on this, but even a researcher, do join the group on LinkedIn. It's really helpful to cater to a discussion that is focusing, particularly on research and finding resources on this. I will welcome next Jens Hunhevicz from the Chair of Industrial Construction in ETH Zurich.
All right, then I'll start with my presentation. It's a pleasure to be back and see all these familiar faces. Last year we did this in Zurich in person. Now it's a bit different online, but nevertheless, it's super interesting to see what everyone's working on. So I'm Jens Hunhevicz. I'm a PhD candidate as well. I work at the Chair of Innovative and Industrial Construction under Professor Daniel Hall. And I'll present you today a high-level overview and summary of some of the work I published last year about crypto-economic incentives for construction. And I think this high-level overview is quite useful to understand or to kind of introduce my thinking around what blockchain can bring to construction, instead of going into all the details. All the work is based on papers. The details you can find, they're all open access online. All right, my first question when I started this work was, do you need a blockchain in construction? And it's a bit funny now to ask this question at this workshop when everyone kind of takes this for granted, but I think it's a very valid question. And I investigated in this work what kind of use cases are proposed to use blockchain for in construction and what DLT design options are available. And then based on some existing frameworks that I synthesized into one big framework, I tried to match these two. I don't want to go into details, but two interesting things came up that I want to share now is one, a lot of use cases actually propose to use blockchain for existing processes. And this has two implications. First, if you take an existing process, all participants are known. And if all participants are known, you could, in theory, use also a third-party service that does the same work as you could do with blockchain. I'm not saying that this doesn't mean, I'm not saying that this does not mean you shouldn't use blockchain. I mean, there is definitely some benefits that you can also apply there. But it's just, you need to be a bit more careful in what cases it makes more sense. And at the same time, the second thing that I noticed is if you move towards cryptocurrencies to use and incentive systems on top of these blockchain networks for use cases, blockchain becomes more necessary in a sense, or you cannot just use another system that does the same as blockchain does. So, and this is often use cases that move also towards anonymity of users and things like that. So I want to kind of introduce a bit of a different perspective. Instead of saying, here are our existing processes, what can we use blockchain for? I want to show you a different perspective. And I want to start with this question, does the world need blockchain? And I want to specifically go into, does the world need Bitcoin as one specific example for blockchain, right? So Bitcoin is this decentralized network that only incentivizes participants to contribute through its crypto economic design. And the crypto economic design in the case of Bitcoin is that it has a deflationary supply curve, so there is less and less Bitcoin issues over time. And it has its proof of work mining mechanics that incentivizes participants to add blocks and secure the network. I don't want to go into details here as well, but this is Bitcoin. And if you would ask the world, do you need Bitcoin? A lot of people would say, well, a monetary system or a transaction system, we already have that. Why should we use that, right? But if you just look at one indicator, I think a lot of people think it's actually quite valuable, right? And nobody asked if it should be there. It just happens to be that aligning incentives through these crypto economic designs seems to be a very powerful thing, and a lot of people find it quite useful, right? So the better question would be to ask, well, if blockchain is here to stay and provide this service, is there really a choice in adopting it? The better question would be, in my opinion, how will it impact the world, right? And you might guess where I'm going now, but I want to move now to crypto economic incentives for construction. So I wrote this paper for the ARCON doctoral workshop that didn't take place, but the papers got published anyways. So I described in there some very high level thinking of what crypto economic incentive system could do for construction. So I want to start with this idea that the construction project can be quite a big project, complex project, a lot of stakeholders involved, and it creates this kind of issue that we call sometimes fragmentation. So because it's so big, you first design it, then you construct it, then you operate it, and each time there are different stakeholders involved and different companies. And in each phase as well, there are again different trades that need to work together. And each time a new building gets built, these old people get reassembled again. So this makes it quite hard to collaborate. And new technologies, for example, BIM, they try to digitize this information baseline so it's easier to distribute information, right? And this is very valuable. But still, as Jennifer nicely pointed out, I mean, people and technology, these two systems, it needs to fit together. And I think there blockchain could have a really strong value proposition on top of these existing systems that digitize construction more and more. So luckily, Theo introduced tokens and smart contracts in the introduction, so I don't need to do that again. But I really like this statement that blockchain gives us this programmable money. And when you can program money or these value containers, you can program incentives. And when you can program incentives, you can program people. Of course, this is a bit oversimplified. I don't think you can really program people, but systems like Bitcoin prove that aligning incentives through like value creation or value containers, like these digital value containers, is actually quite a powerful thing. And in my opinion, you could use that also for real world systems, for example, construction. So the idea would be that you observe what's happening on the construction side, that you digitize this, and you create incentive mechanisms based on this data if a certain behavior is wanted or not, and reward this or punish this depending on like with these crypto economic systems and tokens. And the purpose is that you foster collaboration or make collaboration easier. That's the high level perspective. And I can give you one example that I published at ARCOM last year, where we looked at how incentivizing high quality data sets can be done with blockchain. So the hypothesis was that you can use blockchain as a useful tool to actually incentivize data collection. So we figured that you can say, well, it can automate the collection process, it can ensure a trusted record, and it could leverage crypto economic incentives to assure these high quality data sets. And high quality data we defined as complete, correct, and structured. We then did like several workshops over the year with construction professionals to investigate how this workflow in a typical design with build process looks in Switzerland and when important data drops happen. And we coded then with Remix, now you know Remix, an Ethereum smart contract prototype that has functions that request data at certain project steps. And you can only proceed to the next step if you actually submitted that data. And this is controlled transparently through state variables anchored in the blockchain. So this brings the aspect of formalized and strict process that you need to follow and already kind of satisfies the completeness and structure aspect of data that is needed. But most interesting, what I find most interesting is that you can actually create maybe a system that incentivizes also correctness. So imagine this very high level case, someone submits data, you create a verification process through the smart contract that says, yes, this data is correct. This can be done automatically or through other people. And you reward this through monetary incentives or a reputation token or some other form of reward, right? So that's the high level idea, how you can leverage this incentive system to kind of create certain behavior within a construction system, in my opinion. And it's not so easy to actually design these systems in the end, just that I also have say this. But I think it's an interesting and very powerful idea that is worth more research. And this kind of early thinking about cryptoeconomic incentives also led to my work that consumes most of my time around, and it's how can you actually leverage these systems that in the end create governance systems through coordination of people to actually manage something like a construction project or an IPD, which is this collaborative project delivery systems. Some early work, some high level thinking is published in the working paper of Epoch last year, but I'm still working on this and this is not published, but I'll introduce the high level idea now. So I need to introduce also the concept of the tragedy of the commons so that you know what I'm talking about. A commons, a natural commons, for example, a lake or a pasture is open to all. The resource system is open to all. So if you're a rational individual, you act in your own self-interest and you exploit the resource. And because you want to put as many cows on the pasture and you want to fish as much fish out of the lake as possible to kind of increase your own wealth. And this causes, through this uncoordinated action, depletion of the resource, and you suffer delayed cost from this deterioration, because at the end there is no grass or no fish anymore in the sea. And my professor, Daniel Hall, noticed something similar, noticed some similarities with construction projects here. So you could say if the budget and schedule is open to all, and firm receive direct benefit from their own activities, a rational acting individual or firm is incentivized to take as much of these resources as they can. So they want to use as much time as possible and as much of the budget as they can. And the project, or also some individual companies working, they might suffer delayed cost from this because it's a finite budget or a finite schedule. And interestingly, IPDs, they try to mitigate this risk through kind of setting up collective structures. So everyone needs to be responsible, take responsibility for this through like shared risk reward contracts or some other social structures. And this is very similar to some of what Eleanor Ostrom proposed to manage the commons. She won the Nobel Prize for proposing these 8 Ostrom principles on how you can manage like these lakes or pastures in a decentralized bottom-up way. If you're interested more in this connection between like IPD, construction governance, common pool resource, and Ostrom, I really recommend the paper that just got published from my professor Daniel Hall and Marcella Bonanomi. But at this point, I want to focus on blockchain, which is actually something that I noticed at one point is very interesting. There is quite a bit of literature that proposes blockchain as a way to scale Ostrom principles and common pool resource management. So these articles, they kind of propose that you can use these decentralized cryptoeconomic collaboration mechanisms for the decentralized management of the commons proposed for the Ostrom principles. So the high-level idea is that you can encode these Ostrom principles into coordination rules on the blockchain, and you can enforce these rules as well if needed. And of course, there is also transparency of all these transactions that is also native to blockchain. So it's easy to monitor what's happening in the project. In addition, this also enables integration with IoT, because a blockchain does not distinguish who holds the address. It could be also a smart device that holds the address. So you can create coordination rules between humans and machines for a certain goal. And as well, you can introduce economic incentives to protect the commons. All right, you kind of know where I'm going. I mean, if you realize that there is the IPD governance and the similarities between the IPD governance and the Austrian principles, and blockchain was proposed to manage the Austrian principles, I asked myself, can you use or leverage this technology to kind of manage construction projects in a better way, especially IPDs? And this takes a lot of my time now, researching of my research time in my PhD. And the high-level idea, I just give you the high-level idea for now, and I might be able to share more in the future with you, is that, again, you rely on these trusted digital processes with blockchain, transparency and smart contracts and immutable P2P transaction, but also relying on like the digitized database coming from BIM and other digital processes. And you build these incentive mechanisms on top with tokens and smart contracts to incentivize certain behavior. All right, I think it's interesting. I'll give you also some outlook on what I think might happen in the future with this potential, with the potential of these crypto economic systems. I may very much agree with some literature that says blockchain is a facilitator for new forms of economic organization and governance, and therefore an institutional innovation with the potential to disrupt and substitute existing economic coordination. And the idea, like the simple example of Bitcoin kind of shows this, right? I mean, we do have our current system. A lot of people would say we do not need another system, but it just happens to be that these technologies are around now, and they have a completely new value proposition that a lot of people find attractive in the world. So it grows and it becomes kind of an alternative or an even competition to the existing system. And I think very interesting in this regard is the decentralized autonomous organization idea, where whole organizations are governed through smart contracts. And they enable these kind of, or foster this new decentralized bottom-up coordination mechanism. And Bitcoin is kind of an early prototype of this, right? And this is not just theory. I mean, there is real projects working on that. For example, Decred is another cryptocurrency similar to Bitcoin that aims to be the first protocol level DAO. And Aragon is another project that lives for now on top of Ethereum. They're also moving to Polkadot and Cosmos and other blockchains now, that kind of experiments with building blocks towards DAOs to enable these decentralized collaboration mechanisms. And in addition, I find very interesting that also things like machines can hold addresses. And there is some very visionary articles out there that kind of say if things can hold addresses, they can hold funds. They can hold money or control money. And you can imagine these DAOs to kind of have the purpose to sustain these things. And this could lead to these non-ransaking, self-sustaining things in the future. And McGonaghy describes this as nature 2.0 because he kind of compares them with how nature just is and simply provides. And he says, why couldn't just an infrastructure network like a power grid just be there, provide its service, is governed by the DAO, and is not subject to rent-seeking profit intermediaries, companies that try to make money out of it, but it's governed by a DAO. I think these are very visionary but very powerful ideas, and blockchain provides the infrastructure for that. And Hongyang tomorrow will present a bit of our work around these ideas that in the built environment. So I don't want to take away from her presentation. I want to close with these two. I think these two ideas. So blockchain governance, in my opinion, through DAOs and crypto economic design can enable new collaboration mechanisms better suited for complex systems because they're bottom up, similar to how bees organize or ants organize nowadays. And they're also possible enablers to interact with cyber physical systems. You can directly transact with machines, right? And I think if you now imagine a construction project that is often described as a complex system, and we have more and more robots and machines and AI algorithms doing the work, I think these are very powerful ideas. And in my mind, the question, do you need a blockchain in construction, is very much the focus from the existing system. How do you apply blockchain? And this is a very valid question for especially in the short term. But I also have the feeling, and that's why I go down this route with my research, that blockchain is here to stay, and it provides this value proposition, and people will find ways to use this. And these new ways of coordination might be better than what we have nowadays. And they might be first exist in parallel, but at one point they might compete with the existing system. So I think it's a very valid question to also ask, well, if blockchain is here to stay, what does it do to construction? And with that, I close my presentation. I'm also in this LinkedIn group, and you can also Google me and contact me if you want to get in, if you want to talk or exchange ideas. Thanks.
Thank you so much, Jens. Fantastic presentation as well, and challenging. And I really like it that both you and Jennifer kind of thrown down the gauntlet in terms of what kind of high-level ideas we should be thinking essentially for the future in terms of implementation. I will welcome also now Michele Nati to discuss IOTA. There is a connection there with IoT and the kind of connection that Jens was making with machines and autonomous systems in a sense. And I kind of suspect you might be taking us down that route, but also showing us how IOTA might be working on a infrastructure level. Thank you so much for taking the time to be with us. You can share your screen and begin as soon as possible.
Yeah, thank you. I'm actually now wondering if I have enough context around IOTA first in the slides, or I should give you a quick overview on other use cases.
You can always dream with us if the content prepared is not enough. You can always dream about the future. So that certainly will take us forward.
Yeah, thanks first of all for having me. I've been collaborating with Abel, mainly Stephen as well here, and the CBC already a few times in the past, and we had 1 month ago a workshop explaining how IOTA, it's a new distributed ledger technology, not that new anymore now, could help integrating with the construction sector. Especially we focus on the energy trading and how we can enable peer-to-peer energy trading between renewable energy sources using IOTA features. Today I was planning to somehow leverage a bit of the knowledge we share in that workshop, and hopefully if you already came across to IOTA, to give an idea of what is coming next for IOTA. So we are going toward a very important update of our network. Not yet the consensus algorithm we use, but we are updating various features that allow us to even scale more for an economy of machine, like you said before, IoT, data, and services. I am from the IOTA Foundation, which is a not-for-profit organization based and regulated in Germany, with headquarters in Berlin, but we are all working all over the world, decentralized. I'm actually in London. It's my previous job. I stay in London, even in this job with IOTA. We are over 100 full-time employees spread across 23 countries, maybe even more now. We have budget for 40 million at the moment that came through donations. We didn't really do an ICO. We just sold out the token, and then we ask for the owner of the token if they want to donate some back for this foundation to exist and continue to mature the technology with focus on technical and regulatory aspect of cryptocurrency and DLTs. I will use this slide to give a very quick overview of IOTA. Unfortunately, I didn't include other slides, but bear with me and I will give you some example on where IOTA is relevant in this domain before I jump to the other topic. IOTA, first of all, is born now in 2015, and then the foundation established in 2017 when the first implementation of the ledger started to appear as open source technology to answer basically the current limitation of existing blockchain, mainly Bitcoin blockchain, as well as Ethereum that powers all the world of smart contracts to date. The main issue was that scalability, and the fact that to achieve consensus, remove double spending, all is based on incentives and complex work that only super user that, let's say, miners can do to support the computation capacity required for this process. This introduced, you well know now, fees in order to get transaction process. So you have experience if you do a bit of cryptocurrency exchange or trading or moving across wallet, you have to pay fees that sometimes are higher than the money that you're moving, just because the network is so congested that you have to incentivize your transaction to be worked before the order from the miners, and this is not valuable for a small amount of value that you want to transfer. Likewise, if you have to run smart contracts, you have to deal with the issue of basically paying for instruction that you perform in the smart contract in gas, and this is also very volatile and changing with the value of Ether that makes smart contract not be possible to be used for every single use case and scenario that you want to do it, but minimize the use of that. So main issue comes from the blockchain structure that exists in the blockchain and the role of miners. So that's why IOTA proposed already in 2017 a different data structure that is based on direct acyclic graph, DAG, that allowed to remove this sort of hierarchy in the network and create a much more flat structure where transaction can be processed by any node in the network with the same computation capacity. And all of these rely on the fact that basically more nodes can validate the same transaction all over time. This transaction can reach a finality, which is much faster than doing this with a very expensive computation process. So in this way, IOTA achieved two benefits. One is scalable, parallelized structure for mining for validating transaction that is not possible in the chain of block that you have in the blockchain-based other ledger. And secondly, doesn't require to pay fees for incentivizing this work. So the incentive comes mainly from a collaborative effort, because nodes that have a transaction to inject into the network, they cannot validate their own transactions, but they validate transactions from other nodes, showing that they do some work for a third party, so that that third party will validate their own transaction. So this collaborative effort gives the incentive for the network to work and doesn't require any monetary incentives. As a result, we have no fees. If you talk about data value, transferring value between wallets can happen without fees. So you can start to support micropayments. So you don't need to have any more that moving of value that is higher than the fees that you want you have to pay, otherwise you don't make this viable. And this works very well for IoT. So one example is, for instance, paying for energy consumed at a charging station with IOTAs. That's possible because these are microtransactions, so you don't want to pay, you don't pay large amount of money for charging your car, and this can also be stopped at any time. and you have this real micro fee transaction, a micro payment that you perform without fees, so you can perform this. That's an example of paying a machine for some service. At the same time, you don't have fees. You can actually really use the ledger for storing data, for giving the same mutability that you give to value transaction in the ledger, like you do in any other blockchain. You can give to data that you attach as a payload of a transaction. So because you don't pay, you don't need to move any currency. You can even issue zero value transaction because of there is no required incentive, monetary incentive. You can actually use the ledger to store data. This again scale and works well for IoT device that have a lot of data. So having said that, IOTA work on this principle, offer this capability based on DAG. These days we provide some new updates to the network. We are about to launch next week and start a migration phase that will last 1 week. What is the major update of our network, which is called Chrysalis? So we bring a new implementation of the nodes with feature that allow to scale to 10,000 transactions per 10,000 transactions per second, increase the throughput, leveraging this decentralized data structure that is the DAG. We have a new phase as well coming that it will come later. I'm not talking about that. So what are the novelty that we bring? So first of all, IOTA started in 2015 and then the foundation in 2017 with too many novelties. Like I explained before, we moved from a chain of blockchain to the DAG. We were one of the first, probably the first to move to this direction. We introduced many other innovations. We tried to be quantum resistant. We were quantum resistant, although quantum resistance for signing transaction introduced some downside, like you cannot reuse the same address for moving a value between transactions, so for between wallets, so for recurring payment doesn't work. So we have learned that a lot of innovation that we brought was very good, but create some kind of user experience that is not the best. So we tried to redesign the ledger and some of the APIs and some of the functionality in a way that it becomes much more usable. And that's what we want to achieve from this Chrysalis release. So we see now that we are bringing benefit for developers. So we have still an higher grade security, and we use mainly as a main language Rust. Hopefully you are familiar, you can get easily familiar with this language. We provide standardized programming language interface that works across all the different libraries that we have, different porting. So now we have only one reference interface that you can use to call in different libraries for the different functionalities, the same instruction. And we create also wallet, not anymore wallet that are for you, for the end user to host value, but also they can be used to embed very easily into machine for machine to manage their own machine economy in their own wallet. We have now a 10-second confirmation time, which is much lower than compared to other networks like Bitcoin and Ethereum. And I think 1,000 transactions per second on the normal network. And we are also now a much more greener technology, more than others. We managed to reduce for 60% consumption of IOTA. That is already very low because proof of work is not required by miners. It's only required, and it's now a 2-second spam protection proof of work that you only perform at the edge of the network when you want to issue a transaction, to avoid that transactions are just issued for the sake of creating denial of service. So this is not a problem anymore. So what in practice are these improvements that we brought? First of all, as I said, performance improvement. Overall, we create, there were a few tweaks in the direct classic graph and way of selecting the transaction to approve that we managed to change and increase the speed of transaction per second. Other main improvement with respect to the previous model is that we introduce UTXO. I don't know how much familiar you are with the concept, but basically now every transaction has basically information about all the different let's say coin that have led to that exchange of value, to that transaction. And we have atomic transaction, or all this is embedded into one transaction, where before we used to have a bundle, what is called, we create three transactions to move value. One is the actual transaction to move value between wallet A and B. And then we had a transaction that saved the reminder, and a transaction that wrap reference all of them together. So now we can, with this combining all in atomic transaction, we reduce of 3 times the size of the ledger as well. So, and we support new different signature scheme that allow as well to, let's say, maintain reusable address and embed also in device like IoT device that can sign their own transaction and don't need any more some more computational power device to manage this. And of course, we can enable new second layer protocol that are very useful for use case in the construction sector. New tools, I already mentioned the wallet, the proof of work, something that I said before, you have to create to avoid spam, protection to the network, but before, in response to be much more user-friendly, you require a lot of instruction. Now it's something that happens much more seamlessly with very few line of codes in the device, so that they have to generate transactions. So this already a good improvement. We create a strong gold, which is basically a vault that every device can have and manage and rely to manage and securely store, pair with this, let's say, a safe environment, the hardware safe environment keys for managing all the transactions that happen on the IOTA ledger. So this is particularly, again, useful for IoT device that have to basically either sign transaction in order to show the origin of this transaction from a specific recognized data source from a specific recognized device, or sign transaction to transfer value in a machine-to-machine economy. We can create now with the UTXO model tokenized asset, which again is something very useful in the construction sector, especially in production of building. Let's say, if you think about creating buildings like we did in another project I mentioned last time of this peer-to-peer energy trading. So if you tokenize the building itself, you tokenize the asset that produce energy, this can be immediately rewarded for selling energy to third party. And as well, you can create your own currency. You don't need to tie the value of exchanging energy and pay for energy to the value of a volatile asset like can be an IOTA token. You can create your own colored token as well using this innovation that we brought with the UTXO model, because every token is actually now colored as a label, so you can decide and program token to be used only in specific context. That's something that also will help. And of course, we have introduced already, but we make much more available now, smart contract, which in IOTA are smart contract of layer 2. So basically this require not all the nodes like in Ethereum to run smart contracts, but you can select island, we call committee, of nodes that run your smart contract. And then on that, you decide the quorum, how big should be the quorum for those nodes to come to an agreement and for you to be sure that the contract is executed in the right way. For instance, 3 out of 5 nodes of committee should come to the same conclusion and sign the same result for a smart contract. So this makes the smart contract in IOTA much more scalable. They can run in parallel, and you can see many islands of smart contract running on the same network, on the same ledger in parallel, differently from Ethereum. And you don't have, again, the competition for the resource and the fees associated to that. Immigration roadmap, if you're already an IOTA user, you have to be careful with this, because if you own tokens personally, that's something that affect you if you do using exchange node. This will happen between 1st and 28th. If you're only using IOTA already for storing and sharing data, you don't share value, there is no need of taking care of this migration. If you connect to an existing IOTA node, or you will have your own IOTA node, you just update and your transaction will be still there without any problem. And yeah, I think few example where this can be more useful from now on. As I said, again, you can do physical asset tokenization and generate automated revenue sharing. IOTA smart contract allow for automated settlement in many scenarios. With a centralized identity, you can basically identify guarantee not only the mutability of the data when you share them on the ledger, but also the authenticity of the source that share this data and the IoT device that share this data. This is particularly useful for creating digital twin that actually can be audited for the data they share and from this data where they are produced. Of course, you can have high velocity, high volume due to the fact that the ledger is much more faster and scalable, and different from other ledger. You can actually use the ledger to transfer this data rather than rely on a central cloud where again, there is the issue of who trust, which actually store and which actually goes out. Instead, you can write this directly into the ledger to the scalability. And of course, you can do machine-to-machine payments even faster and with dedicated token of volatility. So these are few of the things that for this construction sector might be of interest and look for. So yeah, I don't know if I went too fast. How much time I still have, or yeah, because in the end I try to condense a lot of things.
You still have time if you need 5 more minutes. Absolutely. Or we can go to the discussion. Up to you.
I'm happy to go to the discussion maybe because yeah, I think one thing that I would like to raise your attention as well is that blockchain is not only a technology. Yes, it's a tool for everybody, and because here it's a workshop and you are discussing use of technology, we are also working with different initiatives and try to promote and create education program and create material that is more tailored to different end users, so not only experts but also students as well, many different kind of users. So I will encourage you to have a look, and I will be happy to engage also on this aspect to get feedback on where the technology can also even improve more than what it does now. So, and what we will do from the end of this month with the Chrysalis update. So that's it from my side. I have more technical details, but I think you will get too detailed, especially if you don't know about all of them about IOTA. So I'm happy to do questions. Thank you.
Fantastic. Thank you so much. And it's really nice of you to highlight the educational workshop set up by the EU consortium.
Yeah.
Mostly because most users will not program the blockchain itself, but essentially program essentially user tools. And this is where it really becomes interesting because they can interact with the infrastructure and really build interesting issues. So
Yeah,
I'd like to invite also Jennifer and Jens to the group, so we can have a discussion. But also I would like to invite everybody who has a question to either you can immediately unmute yourselves and ask the question either to the whole panel or to any of the presenters directly. I think everybody was really, either you were really floored or it was a tiring day. Okay, I'll jump in with a question then. First to Michele, because I found I didn't know the technical details of IOTA, right? So it was really interesting to see this. Even before you popped it in your slides about digital twins, I immediately thought my first question would go on digital twins, because this is something that is really interesting for construction and how you connect essentially devices with blockchain. So the first question is, what kind of IoT devices can we run an IOTA client on, or an IOTA node? And what would you think is the best, maybe user-friendly way to start with on this?
Yeah, very, very, very good point. And I'm sorry, yeah, I came with a follow-up of previous talk instead of embedding all the information for the previous talk that probably for this audience was very important and very good. I didn't mention one thing that it's one of the second layer we have in IOTA, which is called IOTA streams. So if you imagine of a digital twin, and had some conversation this morning with a company, Geogram, focusing actually on digital twin. So you might have the needs of the data create for digital twin from an IoT device, a combination of IoT device coming from IoT device and need to be shared with a third party. So in that case, you want to guarantee that there is trust among these data and how they're shared. They're immutable. So that's probably a good time to put on a ledger and to also introduce decentralized identities so that allow you to verify that the source of the data is actually what you expect to be. With respect to that, the best tool to use for IOTA and digital twin, first of all, you can run this on any IOTA node. You don't need to host the ledger on the IoT device. Sorry, on the IoT device itself. You can still connect to a node that you trust. If it's in your building or something like this, that's enough. Or even you can run an IOTA, a full node on a Raspberry Pi with this Hornet version, but that's not what you need. Anyway, the best tool is called IOTA Streams. Why this is good? Because digital twin basically are made of time series and of data. And if you have to do this with a normal blockchain, what you're gonna do is basically you create a transaction for this set of data, and then the update of this data, you have to create another transaction and so on and so forth. And what is required to keep an off-chain indexing of all the different bits and bytes where they belongs to the different portion of the ledger. If somebody wants to read this digital twin, you have to transmit all this indexing. And this is quite a lot of overhead, especially to keep on an IoT device. With IOTA Streams, basically you can create a series of transactions that are all interlinked together for the same entity, for instance, a digital twin that you define a priori, and then to transfer this information to a party that wants to read from the ledger, you just have to share the first transaction where this first version at time zero of the digital twin is stored. So definitely for creating digital twins, I will look into IOTA Streams, which is one of these tools that comes with a library that exposes this functionality, write and read and subscribe to a specific data flow, and this makes much more easy to implement this. And definitely you have embedded the insurance that this data come from the ledger, and so they are immutable. So IOTA Streams is something that yeah.
I look forward to playing with it, and I also noticed you have a Python library, so that would make it easier to you know, incorporate, connect maybe BIM models to it. Yeah. I have a question also for Jennifer. I mean, you mentioned how important it is that you connect essentially, that we take care to understand the social environment before we try to apply a technology, right? I have a kind of like a blue sky question for you on where would you start in if you were asked to kind of try to implement a blockchain within a construction project. How would you start to do that?
That's quite a broad question. I think
I know.
No, it's fine. I mean, I was thinking about this all day. You know, we can do anything. You can do anything you want, almost anything in the world with technology. But making the right technology to solve the problem is quite difficult. If you're looking to apply, I mean, you would never take a construction project and apply blockchain and smart contracts from day one across everything. You would take a small aspect of it. So this is one of the projects that I'm looking at the moment alongside my, for the final part of my PhD, is the weather ledger that people may or may not be aware of, which was an Innovate UK funded project that's being developed by eHabitation on the technical side. It's in collaboration with a couple of main contractors, the Bam-Nortil, Ferrovial, and Digital Catapult, and the Connected Places Catapult are also involved in that. And what they did was they sat around a table with about 20 people from different companies across the UK, English UK construction sector, and said, all right, we have this technology that we want to pilot, we have some funding to do it, what are we going to look at doing? And the biggest problem was, you know, everybody sees the benefits that this technology can bring, but they're kind of fearful of actually deploying this technology. They don't like the idea of having automated transfers of money. So they had to come up with a use case that didn't involve automated transfer of money. people are happy to try these things, but they're not happy for the money to leave their bank account without them actually putting a tick in the box to do it. So the solution they came up with was weather compensation events. And this is just finished the pilot, and there's going to be different, there'll be a kind of a formal report released, I think, in the next few weeks on how that's gone. So I think what you would do is you would pick one particular problem that you want to solve. So whether that's exchange of information and creating that thread, that kind of time-stamped thread of the information models that go from one party to another, and build in, you know, a timestamp kind of add into, you know, your Revit model kind of, or whatever kind of software that you use, that would be compatible across different systems within the parties of the project. And think about why you have a problem with that at the moment. So what's the root problem? Why do you not have this effective information exchange at the moment? And a lot of the problems come down to people. So you have to try and use the technology to incentivize people to do things better or to do things differently. So I think, you know, pick something that's important that you could demonstrate, but that's not the most important thing, because you don't want to kind of spend all this time and money for it to then go wrong if you don't get it right. And then it would
so committed actors to the problem you're going to try and solve, essentially. So they need to be committed, and but then I would also, I mean, it's always difficult to present blockchain technologies to construction companies, and maybe this is the trick, essentially, to find a commitment. But then it was interesting what Jens was talking about is maybe 5 or 6 years down the line, right? Once you've done the first 2 or 3 projects where we start, you know, introducing the technology into these projects, and people become familiar with it, and then they can start working on a much more kind of decentralized kind of manner. Because I think that's the kind of crux of it, right? You get this kind of feeling of relinquishing control to try and reach a stage where they try to assign some aspect and agency to the blockchain from my point of view. Jens, what do you think about that?
I think I have a comment first to your previous question, Jenny, where you should start implementing blockchain. I mean, even though, I mean, my research is in nature more years down the line, right? I mean, I don't look at how companies can integrate blockchain right now, but I look more about the future potential. But I do have an opinion about where you should start. I think I think you also should take into account the maturity of technology, right? And I think the one thing blockchain for now does really good already is timestamping. And you can do that even with like Bitcoin, right? You can kind of hash your documents, you can put them on the Bitcoin blockchain to say, hey, it existed at this point in time, right? And you prove this existence. And I think that's actually for some use cases quite useful, right? Already in construction projects as well, and in other use cases. I'm a bit more careful when it comes to smart contracts. I think there is still a lot of experimentation around smart contracts. And I wouldn't even after trying this technology myself, I wouldn't trust the state today with really important information. I wouldn't trust the smart contract. I don't like the layer 1 approaches where you put all data on layer 1. I think this naturally leads to centralization because the blockchain gets so big that you can only run it in databases. And I actually like really the approach of IOTA. I didn't know that they now come up with the second layer solution for smart contracts and only keep the transaction data on the first layer. I think that's a really smart move. And I also see that the future of how these two systems interplay. I think Ethereum will have major problems with their first layer at one point because all the data sits on the first layer. That's just my personal observation after a couple of years in the space, right? And your second, Now I lost a little bit the thread. Your second question was about when do you transition to this other system, right? I mean, like I actually don't know, to be honest, right? I mean, what I see happening with other use cases in finance, that there is a development of parallel systems, right? And there is parallel use cases for decentralized finance that are in like competition with traditional banking use cases. And at one point they might get better than the traditional system and people might switch. And this can go very fast. And I'm wondering whether something like this will also happen for construction, that people just realize at one point that coordinating a construction project is more efficient peer-to-peer over a blockchain coordination system. And they start using that system. And at one point, it's like traditional companies that are not prepared to also deliver value for the other in this other world, they're just left aside, and the system switches at one point to other collaboration mechanisms, right? I'm not sure. I really don't know. It's just also an early observation how things go in finance, and I really wonder what happens with construction, right? Because it seems to be more efficient to collaborate directly on a peer-to-peer level, bottom up, than with a lot of hierarchies down the line. In some cases, right? Not in all cases, of course, but in some cases.
I think when companies start to see, when you start to use the technology to increase efficiencies and productivity, and organizations start to save money, or you have these use cases that are demonstrated that those things can happen, then I think that's when you'll start to see people jumping over to use these new systems, when you've got that proof that it works, that the proof of value, which is what Digital Catapult look at. You have the concept, the idea, the proof of concept that works, and then you demonstrate the value that happens by using these pilots. And when you have more of those, and you can show people on the bottom line that they have more money, or they have less overhead, more higher profits or less overheads at the end of the project, then that's when they'll start to use it, because they'll realize that they actually get some, that's the incentive for them. I think that's what we really need to start demonstrating.
Yeah, I think the people that you mentioned in your presentation, Jennifer, the losers and winners, right, of the system, I think everyone has a chance now to be on the winner side. I think that's the nature of peer-to-peer systems, that you can decide to be the end, like value creator right now, or move your value proposition towards that way. And I'm convinced that then you will be still relevant in a peer-to-peer economy. I think companies that make profit through inefficiencies right now will have a hard time in the future, right? Through information asymmetries, through like just the nature of coordination difficulties in the system we have nowadays, they will have a hard time in the future.
Yeah, absolutely.
I think Abel has a question.
Yes, it's also a comment. So for the eHub, they've presented in the conference last year. So, and also the weather ledger. So that's an interesting thing. But talking with Josh and eHub before they applied for the grant and they won the grant to develop the project, they were really looking to supply chains for housing in the UK. And it came across as more than, they were biting more than they could chew. And I think this is by no means saying that they were not capable to come up with a solution for supply chains for housing on the blockchain. Was more like an industry resistance, in my opinion. And then they've redefined their scope as a weather ledger, and they are being very successful with that. And I think this is really great. So I think, so there is a degree of education and training people in the industry. I think this is quite key because, for example, in the financial services, I had a meeting with one of the directors of NatWest here in the UK. And he confirmed to me, I visit the bank, and he confirmed that they are using blockchain now for over 5 years for internal processes. And there's this, people don't even talk about it anymore. So I think there is a lot we can learn from other industries that are technologically more advanced, like financial services, for example, and I see how they are doing things, and I see how transferable this is.
Yeah, and I think, you know, over time, the focus will move away from the actual technology itself and become more about the applications that people develop on based on this application. So what you buy as a company or as a project is the application and what that can do for the project, rather than something that's built on blockchain. It's what blockchain and smart contracts can do to elevate these applications that will be, so you know, there's this whole idea that when it becomes mainstream, people won't actually know that it's being run on blockchain. It's a back-end protocol that delivers these activities that you can't do without it, or you do in a different way, or that adds value. But it's the actual processes that it changes and the application that it sits on. That's where the value is. So at the moment, people don't know what blockchain is, so you have to explain it to them.
Yes, in many ways, I think they don't need to know.
Yeah.
It's almost like people don't need to know how the internet works. They just use the internet, and then we use it all the time. What we need, I think, it's like new models of cooperation, new models of interaction. I think that's when, you know, the process modeling that Jens is developing and you are developing, Jenny, this can be incredibly powerful, because blockchain itself as a technology, it's evolving, it's becoming more sophisticated. Also, BlockDAG is developing in parallel, and this is also may even supersede blockchain in some aspects. We don't know. But how we interact is very interesting. I was going to ask you too, actually, what, you know, because you were talking about the tragedy of the commons and so forth, and there are a number of interaction models out there, you know, from game theoretical modeling and risk and prospect theory, and that they offer alternative cooperation models and a sharing of resources. For example, Evolution of Cooperation, you know, by Robert Axelrod. It's an interesting model. There are quite a few models, especially in game theory, that when you make it a multi-party and you make it what is called a finite horizon game, a game that you play and it eventually ends when enough value has been generated, that the equilibrium of the game changes. So a very classic example in microeconomics is, for example, The Prisoner's Dilemma. It's a game designed for you to release information and confess, so to speak. But when you play that game as a repetitive game, a game that you have many decisions over a timeline, or what is called a infinite game or a finite horizon game, a game that you play until you eventually stop, you shift from losing the game, basically confessing, to a more cooperative game. And this is all to do with the addition of time, of the time dimension. So when you talk about the tragedy of the commons and some process models that Jen is discussing, I wonder if you're coming across those things.
Yes, I saw some early thinking around this, but my personal opinion is that it depends on the use case, right? I'm not convinced that there is a one model that is superior to one collaboration model that is superior to others. I think it really depends on the use case, and the interesting thing is that you can implement most of them through some sort one way or the other with these crypto economic incentives, right? And I personally, I also really like the idea that you can come up with coordination mechanisms that people can come up with their own rules, right? I think that's the most, in my opinion, that's even the most powerful idea, right? I mean, but again, it depends on the use case. I mean, if you want to secure the Bitcoin network, you better make sure that you have a collaboration network mechanism that really works as intended. But if it comes to an IPD project, for example, you can give people a bit of more freedom to define coordination rules whatever suits the location context or the specific project context, and they can design the system within certain boundaries. I think that's how I see it. So it really depends on the use case. But the fascinating idea is that you can implement all these game theoretical collaboration mechanisms with crypto economy.
Yeah, and do you think machine learning would play a role in all of this? Especially when we consider that collaboration games like this can evolve. You can have evolutionary collaboration, evolutionary models.
Like I'm not, to be honest, I'm not an machine learning an expert on these topics. So I'm not sure how this actually affects direct collaboration. But what I really see coming is that things that hold an address can be part of certain collaboration mechanisms. So a smart device that runs their machine learning algorithms and their AI can compete in a design competition process that is managed on the blockchain, right? So they can submit their designs, and if their designs are superior to the one to humans, they get rewarded, right? They get paid. And the blockchain doesn't care if it's a human or a machine, right? But I don't know how they will affect the collaboration. I actually don't know how a machine would like to collaborate. So I have no idea how that would affect the collaboration mechanism.
That I think would be an interesting point to say, you know, we keep on thinking about incentivization mechanisms and we keep on thinking that the recipient of the incentive is a human, right? How do you model that with a machine? And how does that change the discussion? I think the question of machine learning and interplay with blockchain is really interesting, right? At least we've kind of alluded to certain aspects on this on our work, on how you can set up design problems that partly it could be a machine learning agent submitting solutions to it. We did not model it at all in terms of actually making it work, but at least we allowed for the possibility. But you could have other aspects that the machine learning algorithm could take into account, right? So if you have a digital twin, it could analyze, you know, consistently the performance of certain aspects on the digital twin. The machine learning algorithm could help you maintain part of the infrastructure. I think what is really interesting with construction is that, and blockchain in construction, is that we're no longer only discussing a digital system, but we're discussing a socio-technical and physical system. And when you bring in the physical aspect to it, that's where it becomes much more difficult of a problem to solve. And this is where you kind of need, you know, approaches like the one presented by IOTA and Michele now, where it makes it much more easy to solve, to connect whatever you have on a blockchain or a smart contract level, you know, to the physical world. And I think that's the kind of difficulty that we face on that. So I'll ask you all to kind of you know, offer your thoughts as closing arguments before we close the session on that. How do we connect, you know, how do we try to connect blockchains more efficiently with the physical world?
Okay, do you want me to start or?
Yeah, please, please, of course, take part.
So I think there is a question here as well from Emily. How can we use blockchain to improve design for manufacturing projects? So I think you know, in this fourth industrial revolution, which is also being called the cognition revolution or cognitive revolution or the revolution of the mind, it's very much this merge of you know, organic intelligence and digital intelligence. And the fact that we can so tightly manipulate how things are manufactured with digital fabrication and so on, this gives us as an option to close that gap between the digitally manufactured or the off-site manufactured and the digital twin. So the digital twin can really be a digital twin of the physical. There are quite a few good papers on how, for example, 3D print something that has to be validated in a blockchain. So you protect your intellectual property. And this is a kind of something that you have on your, you need an upgrade on your 3D printer, basically. You need 3D printers that will only print something that has some provenance in the blockchain, or has been somehow processed through a smart contract that authorizes that printing. And I think this convergence will only happen when we created that low-tech infrastructure, that managed tech infrastructure, and plug with the systems we have in place at the moment. But I think it is very much happening. If we look at, for example, software ecosystems like Adobe Creative Cloud, for example, it's becoming much harder for you to just grab an image that they offer to you at a cost and use it everywhere. They are trying to narrow that possibility as much as possible. So I think it is coming, but I think we need to run this exercise at a very fundamental level. Maybe there is a new file format for the construction industry, for digital assets in the construction industry, where you take consideration the provenance of intellectual property, and therefore you can trace the constructed physical asset all the way back to its genesis as a digital exercise, creative exercise. But we do see this emerging.
Yeah, I think, should I go next or?
Yeah, sorry, I was muted. I was, up to you. Yeah, you can.
I mean, I think you just asked one of the most difficult questions that there is at the moment, right? Is how do you connect actually these digital systems with the physical world? And I mean, what I've observed so far is that this problem has not been solved, right? I mean, there are many approaches. There are randomization approaches, redundancy approaches that you have like not only one, like you don't only take one information input, but like 10, and if 8 out of 10 are that way, you trust the information. But I mean, it's really a hard problem to solve. And then every ledger has its own kind of ecosystem that only knows the truth within its own system, right? So connecting these systems is again very, very hard. And I think that I think the technological state is just not there. What I see more promising in the near future is that you actually, I mean, create more human-centric systems, right? So that kind of humans, you trust a certain information if enough experts approve this information, right? I think this is an intermediary step between the current system, where you often also rely on expert input, and the new blockchain systems. And at one point in the future, I'm sure there is better approaches how you can kind of ensure trusted information inputs into the blockchain. But that's also the reason why I'm very skeptical about a lot of these NFTs, right? I mean, they link to a certain physical product, and if the physical product's gone, you have a proof that you own the physical product, but the physical product is not there anymore. So what do you do with it, right? I mean, it doesn't give you real protection from it. I think this is different if it's a digital product, right? And you can prove ownership of a digital product. You don't have this issue of linking physical with digital. So this is not a solved problem. I think it's a very interesting research topic, in my opinion.
Yeah, sorry. So a comment on this is it's what about coalitions? When you use trust as the means to an end. So you create, you can cartelize, if that is a word. You can create cartels within collaboration groups, because your trust is only the trust that delivers what you want to be delivered. We see this constantly, like from the smallest tribes in the Pacific Ocean or in the Indian Ocean to American and European politics, you name it. I mean, that this is for everyone, not for Jens, but for everyone. I mean, what would you think about that?
I think it goes back to the social aspect of how you would structure both a team and then kind of like the incentives within it.
Yeah.
If you then get a dominant cartel within a group, maybe this is where the project needed to go. You know, you could also try to answer it like that. I think you need to also have the particular case study in front of you to kind of make certain you are asking the relevant questions in terms of qualitative output, right? What was the output, essentially the outcome that was, because it might be that cartels might be a good thing, and they might take, you know, they might wrestle the group into a good decision-making approach.
That's exactly that, Theo. There is no good or bad. You know, there is just, you know, what side are you? You know, if you are the cartel fighting against a dictatorship, you're probably the, you know, you have the empire and you have the Jedis. You know, so it depends. It's very, very relative. It's just when trust becomes a means to an end that I start to think, okay, there is a degree of sophistication that simply emerge from human society. We do things like that. In some places, for example, in the UK, we absorb that in legislation. You know, there's for example, in planning, you have a planning gain, which is a sanitized side deal. You know, and this is absorbed because it's simply human nature, and if not an exaggeration, it's the nature of intelligence, because intelligence is this adaptability that we have to have. So I just wonder how this, because this can play really well in the blockchain as well with NFTs, but it seems that at the moment the relationship is just that very direct thing. You know, I have that thing, I create a token, and that token represents that thing. You know, the gap is smaller if that thing is digital, but then when
I think people haven't got into the. I mean, NFTs is a really nice particular case in the sense that they've created like the simple contract I showed today, and they haven't created the rest of the ecosystem around it that would allow a much more fruitful collaboration to develop, and that requires, you know, thinking about it, maybe writing the code, maybe using IOTA to connect it to the physical artifact, right? I mean, I wanted to say to Michele, right, we tried Hyperledger and Ethereum digital twin on Raspberry Pi. I mean, it's awful. It's from the point of view of coding it, it was horrible. I know it can be done, right? But it is difficult from the point of view.
Yeah, I think we've done like a few Hyperledger workshops here, you know, as you all know, and spent a whole day just to set up the computers, or half a day just to set up the computers. It was quite a thing. But anyway, I am also interested to hear, you know, Michael's and Jennifer's opinion about this, if you like.
Yeah, should I go?
Please.
Yeah, no, I mean, probably I'm repeating already what has been said before. I think, and I'm not an expert in this domain, but I can say that yes, this link between physical and digital, I think, is where at the moment blockchain ledgers like IOTA can play a role. And of course, it's much easier if something is already digital. I would say I would focus more on the data provenance aspect. Although we can do both, you say, I said already data, but also value. The value sharing, it's something that machine that can pay each other or things that is too advanced. We go back to what was discussed before with Jens and Jennifer, that there is a level. So we have to prove first value by blockchain or distributed ledger good for, rather than go forward the next step, what they can do in future. So that's also my job. And when I talk to people, it's much more difficult to grasp and quantify if you want to open new business model like machine open, talking each other or selling their services. That's something that is too far. But creating that link and the trust in the data, especially in multi-ecosystem where data need to be accessed by different parties, and then there is also need for auditability, especially in construction. So I think that's where I think there is a good gain for using distributed ledger, especially combined not only with the integrity, immutability of the data, but also integrity of the data source. So start to bring the centralized digital identities that tells me that the data comes from the device I expect to come, and it's not another device has not been replaced, and the ability to verify the origin of this data. I think that's an important element that also brings us a bit more closer to be able to digitize also physical assets in a trusted way. So like we said before, disappear, yes, the asset disappear, then disappear also the sensor, then disappear also the possibility to verify the source and the value associated to that. So I think that's where I see IOTA, but also other ledger that have this ability to scale and to go down to the things. And the closer you go to the physical object with the sensor, the more trust you bring. So I think that's where we can definitely explore and bring value in the construction sector, at least from my point of view. Then it's about, when you said machine learning, we have to understand if machine learning it's a tool for distributed ledger or distributed ledger a tool for machine learning. I would say that at this stage, maybe it's more the other way around. Machine learning can use distributed ledger as a tool to guarantee the trust in the data they're processing or the ownership of the model they're using, rather than the other way around when we start to attach perhaps machine learning on IoT device that can decide their strategy on how to sell their services and things like this and evolve over time. So I think that's something that will come later, but I think it will be much more difficult to bring this innovation because of too many concepts together for people that really want to see the result rather than the mean to get there. So yeah, that will be my position as well.
The only thing I would add is that, again, kind of coming back to this social element, I'm supporting a white paper for the European EC3 European Conference. I can't remember what it stands for. But we're looking at human data interaction. And so when you talk about connecting the physical world with the digital world, you definitely have the technical side of that, and there's not, there are elements that don't necessarily have that human element. But when you look at data that is based on human behavior and individuals, you have the kind of ethical issues that go with that as well. So you have to have this issue around informed consent. So if data is being collected about you, whether it's your interaction on a project during the construction of a building, or whether as a user, the information that's being collected about you, it's great to have this ability to collect all of this data through IoT, through sensors, through networks. But do you have the are the users properly informed, and do they give their consent for that data to be collected? And what are the terms for processing and storing and using that data? So I think there's all these different issues that we have to consider. And I think, the GDPR brought around an awful lot of visibility about how people use data that people just weren't aware of. And every time you log onto a website, you go onto a new website now, do you want to accept the use of cookies, and do you accept legitimate interest? And it's like, well, if it was legitimate, would you be asking me in the first place? So people they're starting to understand more about data and how people use that data against them. And I think that it's the same for construction, whether it's for use to manage a building efficiently, but it's really what you do with that data. I think that's kind of the ethical issues around that.
Yes,
I agree. Sorry, go on, Emil.
Yeah, I think I could say, what would we prefer, because machine learning today is not the greatest thing in the world to coordinate collaborative work. It is certainly getting there. So I would ask you, what would you prefer, to fail fast without blockchain for the wrong reasons, or fail fast for the right things, for the right reasons, basically? I think blockchain allow us to, would allow to give, to have visibility in projects. So if a project is not going ahead, or if it's failing, it's because of the right evidence. Would that, do you think this is a fair thing to say, or is too much science fiction? Management
I think
fiction.
everything, there's this saying from a book, I can't remember word for word, but it's about a pendulum that kind of swings one way and then it goes too far the other way and it settles somewhere in the middle. And we have to go through that process. So you have to go through all the different iterations of what will happen with systems if you use it one way or a different way to find the best way. And I think the only reason I'm as informed about data and use and consent and the digital kind of interactions and stuff that I have now is because of the research that I'm doing. For the research, all the documentation, all the papers I've been reading for the last 3.5 years on blockchain and associated technologies. But I think, you know, we interact every day with data, and whether you agree or not, people use it in whatever way they want to, because most people don't want to read the terms and conditions, so they just agree. And so I think there will inevitably be that issue where people go too far and then you come back the other way and find that happy medium that works for everybody, that operates for the greater good, rather than kind of trying to exploit people. But maybe that's the optimist in me rather than the realist.
I agree with Jenny.
Yeah, we have to maintain that optimism, I think. And I think that's the main idea, to kind of think of the greater good rather than just potentially, you know, what token should I buy now to maybe get a slight edge on my earnings. With that, I'll thank you all for your contributions and your time. This has been a fantastic experience. We're going to close the session for today. And I look forward to seeing you tomorrow with a lot more research questions and potentially a lot more challenges. So thank you so much for taking the time today to participate and also ask questions and challenge us all.
Thanks, Theo.
Thank you.
Thank you. Thank you, Theo.
Thanks, everyone.
Thank you. Have a nice evening. Bye.
You too.
Bye.
Thank you. Bye.
Have a nice morning if you're in the US and a nice evening if you're in Asia, and we'll see you all tomorrow. Bye-bye now.
Bye.